Here we go. Sorry for the delay. As always, my OBS for some reason kicked me out of my Google account and I couldn't sign in for whatever reason. So here we are, 2 minutes delay for 3 minutes delay. Very sorry. Okay, let me quickly check the camera, detect some AI gestures. So, what a chaotic start. Here we are. Welcome to part 5 of our Ender CNC series. So, last time we finished up the entire structure. I'm sure my shortcut doesn't work here. The bad technical glitch series continues. But yeah, so we finished up the whole like structure basically of the CNC. I posted also some pictures on Discord of the enclosure that I somewhat finished. But we will not use that today. That will be for next time where we basically fit this into the enclosure. Today, what I want to do is basically finish up all the cabling here on this side of the machine. And also finish up the cabling in our electronics box. So there's some temporary cables here, but this is obviously not how it's supposed to be. But at the back here, this is a prototype part. We have to put the proper one in. If I printed that, maybe we keep the prototype part for now. But yeah, we have 3 Ethernet RJ45 jacks. And this, hey, Mr. DDSI and Patsimir, welcome. Sorry, I totally missed to greet you. And this is on the enclosure of the CNC. So later, this will be basically here. And you see the same spot for the same 3 RJ45 plugs. That's something like I discussed on the Discord already. So the plan is basically to hook up the steppers via steppers and end stops, like all electronics on this CNC, via these 3 RJ45 connections, which gives us 24 pins. If you count the shielding ground pins, it's 27 in total. And that basically allows me to like disconnect this electronic box very quickly. But the RJ45 plugs are also like with the little nose, so they click in, they don't slip out during a job, so they're secure. And I made sure to get RJ45 cables with 24 AWG. They exist, they're a little bit rare, but 24 AWG is the same wire thickness that we use here on steppers anyway, so we don't lose anything. So technically we should be good with the amperage for, I forgot the number, but it's something like 3 ampere. Although the RJ45 ports are not rated for like 3 ampere or whatever, like they're a little bit lower, but still we are good. Plus, we never have continuous power basically flowing through because the steppers will always have like on off. So the real world amperage is always lower than what the maximum is. Plus, we have the 2208 steppers here with the VREF thingy, so we will not crank the amperage up anyways for now. So this is kind of the thing, how we will connect the two. Hi there, RG Repoman, welcome. Morning for you, evening for me. So, but yeah, so basically we do the wiring. I have a fresh roll of my favorite silicone wire here that I use for all the stepper wires and end stop switches. So I think we kind of like started wiring already. What we still need to do is this motor and these 2 motors. And of course, so let me show you. We have these RJ45 breakout boards. This is how they look. So they have the RJ45 plug here, and then they have 9 pins here. And the idea is, I don't have one here now, but the idea is basically to solder 9 pin. Like in reality, it will be some 9 pin and some 10 pin because I don't have enough 9 pin, but like a 9 pin JST header here. That we then basically have one 9 pin plug. That means basically, for example, these 2 motors here will connect on one 9 pin plug. And we do this on both sides, of course, on an electronic box and here on the CNC. And then we can basically have like a bit of a pin out, so to say, where, yeah, it's just like a breakout board. It is what it is. So enough said. You can use multiple connections for the steppers. Oh yeah, technically, yeah, you could do that. You could have instead of 4 cables for a stepper, you can use one complete RJ45 plug for one stepper, and then have always 2 wires for each phase. You could do that, but then we would need 4, and I only planned with 3 now. I don't think we have space for 4. I mean, you could make like, yeah, the printed parts, right? You can make stuff happen. On the control box, actually, we only have space for 3 because there's also like some other plug. Did I not print that? Ah, yeah, even more. Exactly. I recall printing that. So this is the plate for the control box. Never mind that the Z offset is a bit off here, but was too lazy reprinting that. So here we have the same 1, 2, 3, 1, 2, 3, and then this is control. This one is a different connector. So I want to have a little control panel where we can have like a knob to jog the CNC. But I also want to integrate the emergency stop there. So this is the control connection. So I'm kind of running out of space on the electronics box. I mean, you can redesign it obviously, or you can do some other stuff as a connection for the control box. But yeah, at the moment, like we would be limited to 3 cables, and then basically you have 24 pins available. And with 24 pins, you don't have enough for the end stops plus the steppers. So for now, we can do 1-on-1, but if we see trouble later on, totally possible to like change a little bit of stuff there around and use 2 wires inside the RJ45 connections for 1 stepper driver, stepper motor phase. So it totally would work. Hey, the Ravenkeeper, welcome. I went a little overboard and decided to modify the Rodmod version to use AGW 15 rails instead of rods and ball screws for X and Y. Perfectionist, yeah. I actually saw like the HGW 15 rails. Which ones are those? Oh, it's just the normal linear rails, yeah. I mean, yeah, that works. That works. I think price-wise, to be honest, you wouldn't even pay that much more because the rods and bearings are quite expensive as well. Hi, Dom. Welcome. Are those pieces printed on the Satsuma? No, actually not. I printed on the 2.4 because they are actually quite big. Like, I mean, it would have fit, but I wanted to print a couple at the same time. So 2.4 was active here. They are thick boys. So they're not so deep. Yeah, it's a good plan. I was just looking at the new pictures you posted on Discord. The enclosure, yeah, like the enclosure is pretty nice. Like I have it somewhere down there. I'm very happy with how that turned out. I do have to redo the acrylic panel, like that totally cracked. But that was my fault. Like I opted for a 2mm panel because like I didn't want to spend too much money, and the 3mm panel would have cost me like literally 4 times as much. And then like I bent it and I had it under my desk. The bend was the first thing I did. Let me just quickly maybe show a picture that everyone is like in the loop what we're talking here about. Let me quickly pull it up. Yeah, for some reason my shortcuts don't work today. So this is the picture I posted. This is the enclosure basically. And I used a bent acrylic panel, or like I did bend an acrylic panel. That's like a previous iteration of that. So you see here the bend. And during the bending, there was this tear here basically. So like I put too much pressure, like I didn't have enough heat. I pressed it down a bit, and then it didn't crack. It really teared. And this was like obviously a weak spot. Wouldn't matter because later there's like a little cover over this. So I was like, yeah, whatever, I continue. And then I had it sitting under my desk for like 3-4 weeks. And at some point I picked it up and I didn't really think about it. And I picked it up next to the tier and then like it just cracked at that spot. So yeah, but yeah, this was I counted as a prototype part anyways. So I will redo that. The panel is luckily not that expensive because it's 2mm. I can pick it up at the hardware store here for 15 euros. So yeah, not a big look. So you experienced weird Z offset with the Cardo. Usually the Z offset of the Cardo is super spot on. There was something I figured out what was the problem, but I'm not sure. I don't remember what it was anymore. There was something, but it was not the Cardo's fault. Usually, like I have it over there. Like I printed a really large panel, like 28 by 20 centimeters, and the Z offset is spot on. I do use the texture plate at the moment, and I do have to set a Z offset of minus 0.015 to press a little bit into the texture plate. Without an offset, it's a little bit too high, and then it warps a little bit, so I need to force a little bit into the texture plate, but I guess it's normal. I just posted your stream in my Discord. Thank you. The project we have been talking about doing on RJ Rainbow Man 3D. I will check that out. I never had cartridge setup issues, only when my carriage wasn't screwed tight or wrongly assembled. Yeah, for me, I have a bit of trouble with my hot end. Or like with I have a Revo, and the nozzle is ever so slightly bent to one direction. I'm not quite sure when that happened. That could have been pre-Carto. But what happens sometimes is that like because it's like it's I have to replace the nozzle. It bends a little more over time, and then like it can't it can't detect it anymore reliably. And then I retry a couple of times and it works, but it's like not super spot on. I think that also what happened there. And then I have to bend the nozzle back, and it works like for like another 3-4 weeks. But yeah, I just have to replace the nozzle, but they're expensive, so yeah. Rigid cartridge is a must, and tighten screws. Well, my plan here is basically to CNC aluminium parts for the gantry. That's kind of like the long-term goal with this whole thing here, that I can make aluminium parts. And the gantry for 2.4 is quite high on my wish list. Okay, lots of talk, many people here. So let's just jump in. So this is completely done. The only thing I didn't do now, and I kind of forgot about that, to be honest. I wanted to create something to have like cable tie points here and here, because at the moment, like this is completely loose. I think for CNC, it's a little bit less of an issue than for a 3D printer because like it will see a lot less use from me. Plus, it's lower speeds, and yeah, I think a little bit less critical, but still would be nice to anchor the cable here, that we don't get issues there. Okay, but these are done already. That is fine. The only thing is we need to crimp the ends basically to the these like 9-pin JC connector. So what we need to do is we need to install the cable chain here. I think that would actually maybe be good step one. And then we can redo this motor cable and these two motor cables as well. Then I would just say, let's jump into the cable chain. And to do that, there are two heatset inserts missing here. I mean, that works. And then maybe once you have the cable chain on, we do have some soldering jobs to do as well. So maybe we can do that then right after, and then we're already done with the soldering iron. I think that would be like a nice order of things. I have too much stuff down here. I don't recall what kind of like screw we needed there. I'm not sure if this is the right direction, but looking at this, I think this looks like an M320. It's my maybe 16. Let's make it 20. The 16 just pokes out. Yeah, that should work. I stocked up on those. So you're not short on heat sensors anymore. Well, that one is gone. Looking at this, I'm actually not sure if we are supposed to put heat inserts there, or if Ravenkeeper used again a little bit too wide of a hole. But heat insert it is. Because I think that was a little bit too tight. Oh, that's still hot. See? Oh shit. Ah. Well, that did not work out. I'm not sure if we were supposed to put heat sensors in here. Let's try this again. Let's use a new one because I think there's a bit of plastic in the thread. I think also here we have a bit of plastic in the thread. That's not ideal. 4.7mm holes on your cut. Okay. Then it's me. It's definitely like there was too much plastic here. Like I'm not quite sure if something went wrong with the print. But we'll make it work. Okay. I mean, we have to go to the 16 screws for sure. Yeah, we'll work. We do need the 16 screws though, because now the 20 don't have enough space on the bottom. No, definitely these holes are a little bit too tight for me. Not quite sure why, but it is the case. It works anyways. And that's the important part. Okay. Then let's look at the chain situation. This chain is missing the end pieces. I now have a second short chain piece with the end pieces. The chaos here did not decrease. Okay. I have more chains. Where did that end up? Where would that be? Let me check if I didn't take out the chain. Ah, yeah, I didn't. I planned using we had one spare chain left from the switch wire and I planned on using that, but seemingly I never took the time to actually take it out of the switch wire box into the random assortment of parts for the CNC. Should be heatsets, yeah. XY hole compensation size. I don't know, like I didn't touch anything. This is the only part we had problems, right? All the other heatset inserts went in without any trouble. So I'm not sure. Okay. Let's do the following. Let's quickly screw these in place. Check. That looks good. Let's put these in place and then we can find the best length to connect them. Let's use M36. Oh, I'm missing more heatset inserts here. That did turn off the soldering iron. Yeah, that's not helpful. See, that goes in without any issue. This is like, these also look bigger. So I'm not quite sure if I have like a weird part there or what happened. I don't know. But it works. I receive, welcome. Did you sell any printers yet, or still all available? I was just thinking now to create the cable type points. I mean, yeah, I can also quickly modify the parts. I was thinking maybe we can make a small plate between this and the part that has like just a cable type point in the front. But I can also just modify the part and print it again. Like it's not a big deal. The only that's a problem is here, but I think I'll just glue like a small cable type point on top of that. And these are really quick to swap out anyways, so not a big deal. Oh, what I can also do here, because we can only fix it with one screw anyway, we can use the other two to cable tie those down here. Okay, let's see how much cable chain we need here. I quickly get out of the way. This is actually already an okay length. Looking at this, like that works. Then let's do the following. Let's open that up quickly. And put all the cables in. And this one we need to extend. This is too short. And then we should extend it somewhere here where it's not constantly bending. This is a lot nicer to do while the cable chain is perfectly flat. Okay. So then these two can go in. And then let's just pull, where's the start of that? Because now we kind of know how long the cable needs to be. This one is actually so long that we can use. No, let's use this on the other side then, because I don't want to be in a situation where it's like just too short. So let's just say this. I rather waste a couple centimeter of the cable than having to redo everything. So this is one stepper cable for the second motor that we just have to crimp. And then we need to have somewhat of the same length for the end stop that we need to extend. So there I will just take two of like this, like 4-wire cable. This we will park for later. This will go in. Check everything's in, then we can. No, you want to go on? Here we go. And that's the cable chain. The only problem here is the first segment sags now here a little bit. Maybe we should remove like 2 segments, but it will be the same in any position. So I think this will just sag a little bit here, but it is what it is. Doesn't matter. Not yet added more. This means you're making a lot of room for new projects. Yeah, exactly. I have to build the one 2.4 300 and sell it. Oh, you still haven't built it? Well, that's also like a project in itself, I guess. Wait, did we not include this? No. Seriously? We are missing a cable now here. Let me quickly slide that through. Good sworn I put all the cables in. I'm really missing one? Yeah, I'm missing this one. Let me get this out here again. That's a classic me. Why be efficient if you can do it twice? Luckily, half is bad to fix. Here we go. Okay. So we also have quite a lot of cable here. Let me see, this is this one, so we can pull that through. And this one is this one. I do want to have a little bit of slack here, so they shouldn't be too tight. Then this one is the one we need to extend. So there's this 2-wire cable here. So somewhere in this region here, I would cut this now. And then we can solder these two together and make a nice connection here. We'll rebuild the Triton 250 and use index. Do you have any updates, Steve, on when index will be available? I didn't see any update. Was it like Q2 or something? Which, I mean, technically starts April. So I'm cutting one cable shorter here than the other. And I will do the opposite on the other cable. One cable is long. I mean, here it doesn't matter which one is long and which one is not. The only thing that matters is that the lengths are somewhat the same. And that allows us to solder them next to each other. Tiny bit too long. A little bit shorter. Okay. Let's solder our cables. And I want to make sure it's like a solid, nice connection. Because although it won't move that much, it can move a bit, right? So like when I measured or like when I cut this cable, I could have sworn we had like tons of extra length. But yeah, like with the chains, like it just adds a lot of cable length. No idea. We'll wait till the back end of the year as demand drops and kings get out. Yeah, that's all something like I kind of want to have it early because I want to do it on stream here, of course. But I think it's smart to wait a little bit. Potentially they will have like another hardware revision or something in the second half of the year. This is now a tiny bit short here. Let's just solder it. Place it here. Always the fun of soldering wires like this. Let's just do it. They're also like quite floppy, these silicone wires, so. Can't really put them anywhere in a way that they stay where they're supposed to. Oh, maybe that's quite good now they're like in the air. And for those, I can use my third hand. So I'm just quickly putting tin on both ends, making sure to have like the wick, no, not the solder tin on one side and solder iron on the other side. Then it pulls the solder through all the strains. Let's make sure we don't forget our heat shrink. That would also be like another classic me. It's quite a tight heat shrink, which is okay if we get it through. That works. Okay. And then the long of the one side goes to the short of the other. Would be a lot nicer with the third hand. So you can just put both sides in. Let me see if I can just balance this here a little bit. Perfect. Oh, that's not super good. No, it's good. Okay. So now basically the two solder spots don't overlap, so we can just put one heat shrink over and we will not have any issues. And then this will be here on the side of the motor, so there will not be any kinks. We'll most likely pull a little bit more cable here towards this direction, also here. Let's actually make sure to do that. And we have a little bit more cable slack here because I also still want to like, oh, yeah, see it. I want to put a cable tie point here, right? So we need to have enough cable to actually do that. And now, this would be now awkwardly on the corner. So let's just move that. And we can always pull a little bit more here and have it here. That will work. Will work. Let me make sure to have the heat shrink. A little more to the side. And worst case, we can do it again at some point. Also works around the corner. Okay, cool. Then this one we can pull in. Yeah, like a couple of cable tie points here would be perfect just to hold this nice. In 2 minds, to sell the Trident AWD, I don't need all these printers. Well, I would keep the all-wheel drive because it's kind of like super powerful. So I don't like, this seems to be like one of the best printers you have. So I would keep that one, to be honest. Okay, then let's crimp this cable here. Yeah, I noted the cable. I know I already mentioned that. I just didn't mod these parts yet. And here there needs to be something glued on. But then I think I also will glue it on somewhere down here on the side. And I think it will be okay. But these are the small iterations, right? Like if you, this is more or less a prototype, because Ravenkeeper just made one for himself, and we are now like, for some reason, doing the same machine. Small improvements are normal. Okay, that means I need my crimping box. Oh, actually, before we start crimping the wires now, I think logistically, let's quickly finish up the soldering stuff. Then I just have a little bit less stuff on the table, which I like. So we have 3 of these breakout boards here. We have 1 here. And 2 more will, there's 1 more. No, there's the last. Oh, and these are the red ones are the RJ45 cables. I'll grab them later. So these are the 3 that will go on this side here. And to be honest, maybe it's even best to first mount them and then they're already fixed in place. And soldering iron is off anyways right now. So I would use that opportunity and quickly punch heatset inserts into those. Just a second. So let's just mount them first, because then like it's a bit easier for us to keep them or like put a solder there. Then we can also already immediately think of the pin out needed. Nice and toasty. Seems to be a bit chaotic order, but I think it makes sense to do the soldering stuff first. I also have the feeling that my soldering iron is a bit too hot for the PLA. And here, technically, they have 4 mounting points, but I'll just do 2 per board. That should be plenty. We need to see eating cake when it starts throwing chips out. I totally missed this opportunity because I did not buy any cake. So now we need to hope that we don't get to chips today. although this is my goal. Not big chips, but I definitely do plan a cake session for the final installment of the series, where like we have everything together as it's intended. Which, to be honest, like if we finish this today, like there's not too much missing after that. Just have to place it in the enclosure. The enclosure needs some love as well. Like we need to do lights and everything. Okay. So just to show if I plan to mount the link this way or no, this way. This way they fit better. But then now realize we cannot really like solder them out in there already. Because I have to, of course, solder the opposite side. So let's park these for a hot second. And quickly look in my magic box. I think this is what we need. So these are 9-pin and these are 10-pin. So basically we will have 2 9-pin and 1 10-pin. Because I only have 5 9-pin connectors and I would need 6. But I did not feel like buying one extra. So that's that. Because I never need that. So we will have 2 10-pin. And I usually forget that, but the trick is like to put the opposite housing already in, because it prevents the pins a little bit from shifting. Ideally, you already have them crimped because the cable also takes up a little bit of heat. But this already should help a lot. I do have like 2 spares, 1 spare. 1 spare, so we can screw up one time. And basically the 9 pins give us the 8 pins of the RJ45 plus 1 pin extra, which is the shielding. And from the 10 pin, I'll just pull out 1 pin each. So we have 9 pin. Okay. then that can go back in here. We quickly need the electronics box to quickly rescue the last 3 of these from the prototype part. Oh, before I forget, there are 4 more heatset inserts we need to do. Let's not forget those. Before I now build the soldering iron to something else, or like change the tip. I think it's smarter to do them from this side. So these are just like to hold this like little adapter plate in here, or like breakout plate. Yeah, smart to do it from the front because there's a little bit too much plastic and then like closes the hole on the back. Nope, wrong way. Okay. So it's still a little bit off center. It's better. Okay. I missed your comments to this eye. What did you plan for lights? Because the Creative 42 can't control 12 or 24 RGB. No. But I have what I show you in a second. Let me quickly like pull these out. So I do still had, I didn't buy any LEDs. I still had these LEDs here on the back that you see on my furniture. And these are not addressable RGB because on the furniture I didn't want to have the risk of like one LED dying and then the whole like strip going dark. So these are PWM controlled LEDs. They are actually RGB CV. So they're like 2 whites. This is the old one. Flash. And so it's like these are the LD strips. So they have 6 connectors here. I'm not sure if you can see that. The camera is a bit wobbly, sorry for that. So this is 24 volt, and then it's RGB cold white, warm white. And I'm not going to use all the RGB. I'm just wiring up the cold white, basically just to have like work light. And this will be RGB CT. That is exactly what the professionals would call it. And I will basically just wire up for now the cold white, and this will just go to the hot end connector on the Creality board. So low tech solution will work pretty well, and these LEDs are really nice. So they, my goal there is of course just to have like a really bright work area, and they will deliver. They will deliver. Okay, then let's start soldering. Just make sure that I have a nice setup here, and then we can just quickly go through all of them. So I have this like little like skin thing here on my finger. Like I'm super annoyed by that. Okay, that's for after stream. Okay, let me see. That should not be too hot. Okay, let's put it on some nice temperature. And then I think this is relatively straightforward. Once it's warm. I could use my filter, but you know what? We do a couple of those, so maybe it's worth quickly hooking up the air filter. Okay, this is one done. Now we just collect the ones that we did over here. You can actually buy them with these JST headers pre-installed, but I hoped that I can fit two 4-pin headers next to each other. But did not work and the way I wanted it to work. So now we have to do it manually. I have to make sure that I put them in the same orientation. Yeah. So if I wouldn't have gambled on the 4-pin JSTs, I could have saved myself the work and also the hack with the these last two here, they like each other a lot. Here we go. That's the first with 10 pins. So it's a bit off center, but it doesn't really matter. And it's a second with 10 pins. Now we're already done. So now we have all of these, and we can start crimping. Right. Then are we are done with the soldering iron in general. I feel like I have not enough space today. Not sure why, but it feels tight today. Oh, Mr. Desire, I missed your messages again. I'm so sorry. You can also use the bad output then for two different lighting. Yeah, exactly. Like I can use multiple for different things, but like yeah, it doesn't really matter. Like I don't need RGB light on that. And it CNC takes quite some space, definitely. But it shouldn't take more space than the 2.4. I mean, not that much less. And with 2.4, I didn't feel like I was running out of space that much, I think. Okay. So the 10-pin one, did I have them the other way here? Yeah. Yeah. So the 10-pin one is number 1. The 10-pin one is number 1. Let's make sure to match that on this side. And then the rest are fair game. I do need some M3x8 stuff to continue this. Actually, took me quite a couple of attempts to like get the spacing of all the screws and the plug correct. I think like 4 or 5 prototypes until I got it right. Oh no, there was not a 10-pin. For some reason, it looked like a 10-pin to me, but it was a 9-pin. Oh, there's a small issue in the printed part. There's a little like why does this not fit? There's a little corner here. Let me quickly that comes from the chamfer. Now it fits. Oh, and it's the other way around, and then we have a winner. M38. I was like re-looking quite a while. Let's save, take note of the pinout. Yeah, we will do that in a second. It took me quite a while to decide which connectors I wanted to use there. Like I went through quite a lot of connectors, and kind of the requirements were that it's say like it must have one requirement was like a hardware lock, and the RJ45 have their click, right? They can't slide out on their own. There was one requirement, and the other requirement was like 24 AWG wire. And a lot of these connectors that have like a lot of pins, they have very thin wires. Example, HDMI, for example, has like more than enough wires, doesn't have the hardware lock, but has like, yeah, also doesn't have like thick wires inside. And then there's like a lot of these like serial connectors. I forgot the name of them, but you get them that you can do them yourself, but then you also need like the wires with like 24, and like, yeah, it was a bit of a mess. So in the end, I ended up with, oh, it was completely off camera. I'm so sorry. I was completely off camera. So at the end, I had the RJ45, and this is like a VGA connector technically. Well, technically it is, and this we will use for the control panel. So this is our control breakout board, which I think is quite neat. And you are still missing one of these. Oh, that's not straight in. No, it is. My bad. Perfect. And this one is a 9-pin, and we would have needed a 10-pin. So to quickly swap it out. Must have been in the wrong bin here. Yeah, that was correct. That's an 8-pin. This is 9 pin. Must have been in the wrong bin. Let me put it to its friends. Yeah, technically, we could have used 8 pins. I had more than enough 8 pins. I'm not sure if it makes sense to connect the shielding to ground. So basically, like the pin out here is. Oh, I also see this is collides a little bit here with this one. So potentially we have to desolder that and solder them on the other side. That's for later. Let me not tighten it down all the way here. Okay. Then now we can start crimping actually. Let's use this one first. We can start with the motor wires on one side. Maybe it's good to just do all 3 motor wires. Then we can do the crimping on this end in one go. Classic. Perfect. I will collect that later. It's actually not that bad. Let's just do it. And there are like 5 on the floor a bit later. What I wanted to do is this. Okay. Then we need, I always get it wrong, PH are the small one, XT are the big one. Is it correct? Yes. So we need 4 of these, and just grab a couple. So on this side, we need the small connector. Which I also don't have too many left. So we need 3 of these for 3 motors. Let's quickly do that. Luckily, like these silicone wires here, I really like them for a couple of reasons. One is they are really easy to crimp because they're a little bit squishy. So once you have the connector a little bit pressed on, it just stays quite well in place. That makes it quite easy to crimp those. And I always need to double check that the connector I'm putting on is actually the small one, because like a couple of the big ones made their way in a small bucket and vice versa. So it's always good to do like one double check. And they're also like very easy to mix up. They look almost the same. I'm always looking at the little like nose because that is significantly smaller for the smaller ones. Okay. Then the connector, as always, the outside goes to the outside and the center ones are over cross. Which direction doesn't really matter for now, because we can later invert it in software, basically. So if we get these wrong, they spin in the wrong direction. So outside, then the left center goes to the right center, and the left center goes to the right center. So the center pins are over cross. And the stepper cable is born. Let's put it here. Let's make sure to pull that through. The silicon wires have quite a lot of friction with each other, so if you pull one, you kind of pull them all a bit. I think something like this should work. Put this up here. Then we said this wire is like very long. So this breakout board will be somewhere here. So worst case, we need something like this, which still gives us enough cable to do this motor here on the far side. So let's just snip. Smart people would have labeled the cable quickly, but we will figure it out later. Yeah, I don't need to have the motor here, so we can just quickly make the cable. And you forgot a nice outside what is the SVW? SWD. What did I miss? Okay, so this connector, we will just repeat what we just did. Single wire debug. Do I need that? Oh, yeah, now I get it. Well, we can still put this on the control panel on the front. I have some spare pins. I have some spare pins left on the VGA connector. So we can still do that. Would be very handy. But the catapult flasher setup will work perfectly. That did not work. Catapult is nice once it's up and running, yeah. Well, to be honest, now like I learned a lot from this like flashing adventure. So if I would need to do this again, I would not even bother with the SD card and just do it with the debug connection straight away. That's my take on that. Works very easy. Like once you have the hang of it, and once you know you don't need anything but a Raspberry Pi, like so also here. Left center goes right center, right center goes left center, so they're over cross. Oh, this looks a bit wrangled. Yeah. This was not a good crimp. Let's try again. Orientation somewhat correct. This is, oh, nah, well, this is crimped in the wrong way on this end. Let's quickly plug this in that we don't lose where this goes. This one is also like on the short end. So this one should end up on this plug. So I think the 10 plug we will use for the end stops and stuff. And this is okay. Let's do one more cable that doesn't have to be honest. No, I don't want to risk it. Let's just make one more cable here. I'm always trying to save like cable and like reuse as much as possible. Like in the end, it's not worth it if it's just too short at the end for like 2 centimeter. I tried and was right. Your sim bootloader is working. Just need USB to TTL and QProgrammer, but SC10 is 10 times faster. Yeah. I mean, it's just nice that you can just do it with the Raspberry, right? You don't need anything extra. The Raspberry you have anyways, and technically you can just plug in the SWD connection thingy. You can just leave that in place, right? Like you can just, instead of using Catapult, you can just use that. There's no harm in just having the debugger connected. At least I don't think there's a harm. Correct me if I'm wrong. Okay. That was luckily the last one of the small JST. So from now on we go one size up. This one goes here. Okay, cool. Then I can put these back. And now we have to decide on length. So the thing is, like, we have a lot of space here, so we can leave the cables a little bit longer. Like, there's no punishment on having the cables a little bit too long. We have a nice space to store them. But all of these need to go in here. So, I mean, one thing what we can do is, and maybe that's not the worst idea ever, we put one stepper on each of them, which gives us 4 extra pins. So we do one stepper and one end stop on each. Does it work? No, we have 4 steppers. Okay, then we just fill it up. So then let's do the following. Let's just cut these to somewhat the same length. The first pin needs to stay free. And I think let's try to rescue or reuse these pins. Not sure will be successful, but we can try. No, I have to recrimp this one, which means I will recrimp both of those. Okay, so then basically we just fill this up with maybe the 2 Y steppers. Maybe that's nice to have 2 Y steppers in one thing. Ah, shit. You can always use it for what it is intended for, debugging monitor register and add breakpoints. Yeah, exactly. I mean, I'm not going to add breakpoints to Clipper. Okay, so one has to stay free. And then we have the end stop here. Then let's crimp this one here. And then I wonder if it's smart just to do them pairwise, that we now basically do this, and then we do the same on the other side already in the electronics box, because then we maybe have an easier time not mixing stuff up. Because preferably I only do that once. Aye, bad crimp. Let's try that again. I think on the other side, I will just reuse the cables that we have, the Creality cables. Because then we only have to crimp one side. Although I'm sure it looks super fun, I'm actually not happy crimping a bazillion cables. I'm actually like wondering now. I mean, it doesn't matter per se if we mix up the order of the stepper wires from like this side to the other side of the breakout. Oh, bad crimp. Because like again, like worst case, like you invert the direction of the stepper. Like you can invert it with software again as well. But still, let's try to keep consistent. Just start with, there's one of these black cables has a white marker. Let's just start with this one. Which for some reason doesn't want to click in place. No, it wants. Okay. That's already the first motor wired up. Now we can basically plug this in here. All in one go. We still, oh, we also have to pay attention. There's one shielding cable, which I don't want to use for these type of things. Very quickly, I need to check on the other side. Yeah, we already used the shielding cable now. Yeah, shit. So the first pin, on this side we shouldn't use. Which already is amazing now. But let me keep one of them out as a reference. I don't want to use the shielding. I mean, technically you can, and you can also combine the grounds of multiple end stops and stuff like that, but I want to keep it simple. So the first one, now let me think. Yeah, I think we have to push them all out. I hope I get them out without breaking. At some point, maybe I should buy this official like Molex tool to depin. And these are so far good. Yes. Yes. Let me quickly bend these back out and hope that I get all of them. I think we got away with a blue eye. Black eye, it's called in English, I think. Yes, perfect. Okay, that means we have to keep 2 free from this side. And for the other, because this is a 10-pin connector, for the others we have to keep 1 free. And again, we said we start with the wire with the one white stripe. Perfect. Oh, okay. Then let's also wire up this one here. Let me see if I can reuse that. I think if I press with the let me see if I can get you also a little bit closer to the action here. If I press it like this flat, I think I have a lower chance of breaking the pins doing this. The risk is always if you press it too hard, like you press it in and then like you have to recrimp. I think if I press like this from the flat, it's like harder to press in. This one is stubborn. Yeah. See, can I rescue it? Yes, I think so. Nope, that's a recrimp. Too bad. I just need to grab more of these crimps. I totally underestimated how many crimps this is. I mean, you can calculate easily, of course, but it is a lot. Um, Never had issues with signal on any of mine, really. I feel like I missed like a lot of messages. Let me quickly catch up in a second. Okay, this is complete. Only thing is, yes, it fits through here because this is later like where the axis opening is. Let me see if we can get it around the corner here. Yes. Yeah, perfect. Sweet. I think this one we can put back in. Do it on the E3CNC Discord whipped up an actually nice build manual. Well, I could have used it. I guess it's then for the standard E3CNC. Love it when people pay it forward in open source. Yeah, I mean, I will publish my electronics and my enclosure. I want to beta test it here now in the build, of course, but like once we know this is all like working, I will also publish that. And I mean, I think it's a nice enclosure for the CNC. Other people might have different preferences, but I think for me it will work pretty well. Perfect. Now, like, we still have a little bit of slack here, so we can like organize the cables here. Okay, then let's do this on the other side as well. So we need to wire up this one. And so let me quickly check. So we have these cables here. They're still baked in hairspray, so hey. But let's just use all these cables here. They are way too long anyways. Maybe I should quickly mount that. Let me see like where they end up. Fits a lot better than the prototype, which is great. Okay. So this will be roughly this length here. Where did I drop the second one? Here. But let's actually wire them up as we need them. Let me see. Do I have like... Oh, that's actually good. So we can use this one without crimping, because one is the end stop with 3. And then one is 2, so we don't have to crimp anything on this side. That is what I love to see. Let's get them roughly the same length. Okay. So let's crimp some connectors here at the end. Now we just need to see that we get the order correct. Although we can also like fix like the end stops, we can also later fix in software. So it doesn't really matter too much the order here. So it's the only important part is that end stop, then stepper, and then end stop. That's the only thing we need to get right. And what we also should do on this side is we should connect the shielding with ground, but we can do that later. I don't think this is really needed. Oh, the shielding on ground. I think it's just nice to do that. I was also thinking technically you could use the shielding to transfer signal. Then you have one extra pin per cable. For example, you could put ground on the shielding and then only have one pin for each end stop, or one wire for each end stop instead of like 2. Like right now we just patch it through 1-to-1 how it is. But you can optimize a lot there to get more stuff through. We could get RGB actually through if we okay, so this needs to just match. So from this side to 3, and then we put the first end stop. Let's do the second end stop. Not the prettiest crimp, but will crimp. Okay, then we have 1, 2, 3, 4, 3, and then the last 2 we have end stop. Okay. Then we need to crimp these 4. We're reusing even the cabling from the ender. Shielding is good for long run, but I'm thinking which wire order is better. Keep one phase of one stepper in one pair or split it over 2 pairs. I'm not quite sure if that makes any difference, Mr. Design, to be honest. I mean, technically we can change it later on, but I don't think it makes any difference because like the pairs only really matter for data, right? Plus the pairs will interfere with each other to how was it? I don't get it together. But it had to do with interference, like they negatively interfere with each other to cancel out something. They cancel out something, but we don't transfer data here, so I don't think it makes any difference. That is a very ugly crimp. Let's try that one again. My crimping mojo today is medium. The noise will come from the 2 phases of each stepper. Yeah, but like I don't think you will have noise on the actual stepper signal, right? Like if you would now like run like some data next to it, yeah, sure. But we don't do that, right? It's just electrical power, basically. I mean, if we see any issue, we can fix it by just changing the pins. The thing is now I don't have a white cable, so let's just put them in and see what happens. Okay, that's the first one. That is the first one. Could have kept this a little bit shorter, but it is what it is. Okay. The only thing is like we now connected the Y one step on X. I don't know the order in which we configured them. Like we can play around with this later in software. It doesn't really matter. Let's do this one. And also here. Um, the only thing important is I think that for each plug, the cables are somewhat the same. So I will now randomly take a second stepper. And I think it's also good if the cables here are not too short, that you can move the CNC out a bit. I'll just cut them to the same length. And then this one will have 2 steppers. And then the last one will have 1 stepper, 1 end stop, and the light. With differential pairs, but my point is Ethernet is 40 with the pairs, and if you mix end stop with a face of a stepper, I think it can cause issues. Maybe. I don't. Let's see. I don't think so, to be honest. Because Ethernet twisted pair is only needed really because like you transfer like tons of data, right, over this like one wire. And then like every interference causes like a lot of issues. Right? We don't deal with like sensitive data here, right? Like let's see. Because also in like the standard ender cable chain, for example, right? Like all the wires are just on top of each other. It's also not a problem. Oh, okay. Then we keep the first free and we start with the white cable. Let's just keep that like a little bit like our rule. Just double check. Yeah, that's the first is free. Okay. I didn't take note, no, but I copied it already over, right? So we did it on this side and we did the same on the other side. The only thing we need to check later is if the end stops are the correct ones, but I think I would just try it and then just shuffle it in the configuration. Because I'm not sure which cable this is, to be honest. Like, this is one of the two motors. But I couldn't tell you which of the two it is. For some reason, sometimes it crimps bad, or like I crimp bad. I think it's by far the most crimps I have in a stream so far. This is the third time now in a row. Here we go. Okay, then we start again with the white one. Okay. So here. Okay. And then on the other side, we need to do two motor wires. And we all know you love crimping, yeah. It's my favorite. So, two motor wires. And that's number two is this one here. I'm trying, like they have little yellow labels. I try to match it here. I'm not sure. If I have a Z of that. I might not have the Z. It would be sad. I see it. Not the Z end stop. which we'll also need in a second. So let's just check it out. No, I don't think I have. I mean, it doesn't have a Z sticker, but this is what we roll with. This goes in here, and we just make it the same length as the other one. It's actually quite nice putting this together now, because I kind of planned that like many weeks ago, how this like electronic breakout can work and stuff, and how the case looks, and it's just nice like to put it finally together. So here we go. Let me take this off. The first one is free. Double check. Yes, the first one on this side is free. Then we have one stepper. Okay. And then we have one more stepper. Bit too much bare wire here. Let me shorten it a tiny bit. Luckily, these Creality cables that are quite good for crimping, I think. Would be horrible if they were hard to crimp. Another option here would have been to just solder the cables on this side to the connector, or like the breakout boards here. I figured this is a bit nicer because then you can also disconnect them. You can change pins easily if you need to. And one more motor. Okay, let's put in one by one. Perfect. There will be quite a lot of cables here at the end. I think I can already put on this cable channel cover here. Kind of bring a little bit order into chaos. These cable channels will help a lot to like bring order in chaos here. Okay, cool. One more. And then I don't want to see any crimping anymore for quite some time. Yes, so we have two end stops here. And I think I will just leave, I mean, the shortest cable here determines the thing. Let's just cut them all. So that's two more end stops and one more motor. Maybe I should hire somebody to do crimping for me. I was not sure if you can order something like this, like ready-made somewhere. If you just say like, oh, this is my, what's it called in English, cable tree. This is what I need. These are the lengths. These are the connectors. Make me something nice. That would be tremendously cool if that existed as a service. Let's do the other end stop. That was my tweezers. One more end stop. And one more stepper, and then we're done on this side. Did I miscount here? Because we didn't have the lights yet. Maybe I fucked up. So that's 4, 8, 12, 16, 20, 22, 24. Yes, I fucked up. I didn't calculate with 2 end stops on Y. So that means two options. Option 1 is we use the shielding for 24 volt. Not sure if that is smart. Option 2 is, I mean, now I'm done. I will finish it this way. Option 2 is that we need to share ground. Or not ground. I need to see how the end stops are wired up. I think they're like all linked to 3.3 volt. So that we share the end stops because we have 4 end stops, which is 8 cables. We can bring it down to 5 cables if we share the 1 pin of those end stops and only have the signal that goes back from the switch separate. So for now, no light, which is okay. That's all wired up. Then here we have the last stepper. Let's see if I can copy it. We got it in here. And we have 1 end stop. And there should be 1 more end stop cable. I feel like I had that already in my hand. Maybe I did not, then we have to make one. Yes. Okay. Let's quickly make 1 more end stop cable here. I want to be done with this. Should I ground between end stops? Yeah, I think that's the... Are the end stops on ground? I think they're on ground, right? But to do that, we have to change the wiring on both sides a bit. And I'm not in the mood for that anymore, to be honest. I want to get done with this here. So I think, I mean, all the important connections are through. So that's good. We don't have light, but this is something we can solve later. Let's put this in here. This in here. And then this looks quite neat here. Oops. Let's see, this doesn't need to be that long, maybe like this, plus one extra little bit. Then we have end stop, and then the stepper. The last ones. Yeah, a bit annoying. I calculated through, but I think I did not realize that there are two Y end stops at this time. Because I only noticed that really when we put it together. Which is a shame. Looks like a funny crimp, but it works. Okay. This is the orientation. 1 free. Yes, 1 free, and then end stop, end stop. And then last but not least, one last stepper cable, and then I would quickly clean up and we can turn this on. I totally underestimated how long this takes to fire this thing up. Just thinking how we can share the ground for the end stops. I think the easiest, Mr. Design, let me know what you think. If it's really ground what the switches need, I never get it straight with end stops, then maybe it's actually smartest to just really use the shielding as ground connection. And then we can remove one pin from each end stop, basically. And we just do like a Vago connector in here with like ground, like a five pin or like a 5x Vago with ground. And then we can put the light on one of the 9-pin plugs because like we have two 9-pin plugs with two end stops each. And then we would get two extra pins on each of those. Which is 4 pins, which actually would be 24 RGB. But yeah, not white then. So we're still missing one then. Woo. Yeah. Oh, I'm done with crimping, literally. Let me quickly clean up here, just enough that we have a little bit less chaos. Which I will keep these cables for now. We might need them for the rest of the wiring. Then I have a trash here. Hi there, welcome to the stream. Let's quickly get rid of all these like I will have to vacuum clean them later. Okay. Then moment of truth. You see, maybe I'll keep them together for now. So I put it's better to open them. Number 1 and number 1. Number 2 and number 2. I will later make like a nice combined cable from that. And number 3 goes in number 3. Let me see how I can organize that easiest here. I think this actually kind of works as it is. The Ethernet route will look so clean. Yeah, like this will be nice. Like if my idea is to print like little clips that I route them perfectly parallel to each other. Just without these twists here. Let me see if I can remove the twist here. And it's of course red. Like I made sure to also buy red ones. It needs to match, right? Okay, this is off here. Shall we check for shorts? I don't think anything can short out, to be honest. So let's just fire this up. No magic smoke. In retrospect, maybe like these are like 1 meter, maybe half a meter cable would have been better. But yeah, that can be changed, of course. Yeah, the thing is like it's not only about the color. These also have a 24 gauge wire inside. That's what makes these special. Like this is not the Ethernet cable technically. It's an RJ45 cable with 24 gauge wire. Because like the steppers have like quite significant energy, of course. And you want to make sure that the cable can support it. Okay, wrong one. Carla, this being 1 meter, I should be able to move that kind of over here. Just here's relatively short, but it's okay. Okay, let's quickly check the end stops. As Mr. Design I noted, it's completely random, and one end stop is triggered, which is not good. But if I press one here, yeah, so this is stepper X, so this is already wrong. This one is the one that doesn't do anything at the moment. That's good. So that's the one that's already triggered, which is incidentally the correct one. Then if I press this one here, this is Y. And this is Z. So we need to swap the end stop pin for X and Y. Yeah. So if we swap X and Y, end stop pin is PA5 and PA6. So we just swapped it. I don't care about the labeling on the board. That's all over the place anyways. You can find Ethernet patch cables in every color you like. Don't forget the motors are not energized yet. Nope, they are not. Let's just make sure the end stops per se work. So this should be now Y. Okay, and this one should be now X. Yes, perfect. The only thing is now we need to check why this Y end stop is not end stopping. So this is this cable here. It's this one. So on this side, I would say this looks good. You can do some multimeter testing. Stop. I remember why. We had to change the pinout on this cable here. And one of these two cables had to go to the center. But I do not recall which ones that had to be. Or which one. We had the same one. We need to pin out again. Where did I have the pin out last time? I think Ravenkeeper posted one. Oh, do I by any chance still have this cable flying around here? No, it doesn't seem like. Annoying. Yes, we're using the filament sensor pin as an end stop because we have 4 end stops now, which is one more than the board has. So the pins don't really matter, right? For the microcontroller, pin is pin. Right, is it in this fancy new build manual? Wiring and electronics. Not yet. We don't have that yet. No. Left one looking. Mr. DSI. So looking, the noses here are on top. Not sure why this doesn't focus now. The one that has the Y label goes to the center, or the other one? Which of the two? The one with the yellow label or the one without? Let me put my tweezers. Oh, yeah. Either one. But if we do the wrong one, we have to change the software config, right? Don't use the right one. You mean the right one, this one here now? If I plug it in like this? No, you don't see it. So this one I should not use. So this one needs to go to the center. I don't want to crimp. No, the left one. Okay. I really don't want to crimp. Please come out. Yes. So this looks good. Waiting for your confirmation, and then I push it in, and then we test it. Yes, that I have. So the left one is empty, then the center and right. That looks good. It's okay. Okay. Then let's test that. Yeah, now they're all open. And if I now press this one and refresh, yeah, perfect. So we have 4 end stops. Then the next fun part is stepper bus. Stepper bus, stepper equals stepper Z. So now we kind of have to like see which stepper is moving. Oops. This one is stepper Y. So we need to swap stepper Z and stepper Y. Let's do that. Without swapping the end stop pins, because the end stop pins are okay. Save and restart. Now stepper Z should bus if I do bus stepper Z. Yes, this one is now moving up and down. Perfect. Next one, Y. Should be this one here. Yes, this one now moves. Then we also need to check Y1. Yes, this also moves. Perfect. And then with X, oops, there was YX, that is an error. Now this one should move. Yes, perfect. That means we have all steppers and all end stops. So technically, now we need to check the direction that they work. So we can just do set kinematic position X 150, Y 150, Z 30. And now you see it jumps to home. So let's just start with X. X is inverted. X moves currently in this direction, which is wrong. Y is also wrong, but wrong on both in the same direction. It's good. And Z is correct. So we need to invert X and both Ys. And we do that by setting the direction pin with an exclamation mark. Let me quickly. So we just add an exclamation mark here, or remove it if it already has one, like this one. And where's the Y1? There's a deer pin that's not. Okay, let's try it again. So Y, if I now do plus, should move. Oh, wait, I'm so stupid. Y was correct. X is now correct, but Y I broke. My bad. So we removed the exclamation mark from both Ys, save and restart, and now it should be correct. Yeah, Clipper's amazing for stuff like that. It's just like, imagine you do it with Marlin every time you have to flash again. Okay, X moves away from me, positive, perfect. Y moves towards me, positive, and Z moves up. Let's fire that. I don't like the drag chain here. Like, it's really like hanging down. Like, it's not a problem, but yeah, not nice. And all the end stops work. We have homing. Now, how does it work for Z and stop offset? Do you set it for each aluminum piece that you grind a Ravenkeeper? Well, I can answer that. It works completely different because the Z0 isn't really a thing for CNC. It really depends on your workpiece. You can either set Z0 to the top of your spoil board. But what I see a lot of people do, especially for aluminum, you can set Z0 to the top of the workpiece. And what you do is actually have that already, like your spindle has the tool, right? So you have an end stop for that, which is here. I'll have to figure it out still. But I think I will put, which actually would have been nice to factor in already. Oh, most likely I will put two Wago pieces here that I can connect the parallel end stop, so to say. And then one, you use an alligator clamp on the tool, and you use like the second one as an alligator clamp or something on the workpiece. And then as soon as the tool touches the workpiece, you have an end stop. That's how that works. So the Z is very weird. Also, like usually, like you don't use 0, 0 as 0, 0. You basically you home towards your workpiece, but it's not automatic per se. Like it can be automatic. For me, it's not. So basically, you find the 0, 0 coordinate of the workpiece. So we will use set kinematic position a lot. So it works a bit different than for a printer. Either paper test plus manual jog or touch plate if you have spare pins. Yeah. No, for me it won't be spare pins. It's really like luckily like this cable has a bit of slack here still. So I think we will wrangle some Vagos here. Maybe I have to pull a little bit of the cable in here. But yeah, this has enough slack. Then we wouldn't have needed to solder it. Ah. But yeah, this is kind of the idea that you, I mean, we'll figure this out. But like two Vagos here, and then you can put your own end stop there. Or maybe not Wagos, maybe like two connectors, something. I'll figure something out. And I think on top would be nicer, actually. We'll figure something out. Cool. I hope that we get further. We still didn't install a tool. So I would actually cut here because like it's already longer than I usually stream. And then I would suggest we make chips next week, because then the only thing now we need to do, right, we have to install a spoil board, which I will use temporary for now. And we have to set up the tool. That's the two things we need to do next stream. But all electronics work, or pinout works. We can move stuff. So that's pretty cool. So we are getting pretty close. Oh, and we have to figure this light situation out, but this is something maybe I do that on Sunday if I have energy and time for that. That's next week. Yeah, I promised, I overpromised and under-delivered. I'm very sorry. My energy is also pretty much done after all the crimping. Like, holy shit, was that a lot of crimping. But this looks quite clean. I'm very happy with this electronics box. We still have to mount the Pi properly. I do have a Pi mount that goes here on like here basically. And we have to install the door. So a little bit of work. And we have to add fans, 100% fans. I do feel like that whoever had this printer before me was already playing with the VREF, because these stepper drivers and the steppers are hot. Like they're really hot. I mean, I don't have cooling at the moment, but still, like I would have expected them to be like warm to touch, but these are really hot. So yeah, and for XY, Mr. Design is the same, right? Let's imagine this would be my workpiece, and I mount that somewhere on the base, right? Like you cannot mount it precisely usually. So I mount it here. So imagine the tweezers would be my tool. Then basically my goal would be to home on the top of this box or of the workpiece. And then you need to find the side of the workpiece and the front of the workpiece. And then usually you would cut in the workpiece, right? You leave some margin around. So if it's not perfectly 90 degrees on the machine, it doesn't matter. but then basically this would be your 0, 0, and then 0 is top. It works a bit different. We will work with this machine on stream, so you can see that. And I didn't do that yet. I just watched tutorials on how to do it. But yeah, it's a bit different than the printers. We will do that on stream. Cool. Thank you very much, everyone, for tuning in and staying with me through my crimping adventures. Yeah. Enjoy a weekend. See you next week with hopefully some chips. Until then, bye.